So when we talk about rational functions and their graphs, there's a couple of things that we need to know before we get into that. And the first one is, what is a point of discontinuity? So there are two types of discontinuity. There's removable discontinuity and non-removable discontinuity. Discontinuity is literally talking about your restrictions. So there are restrictions that can be canceled and reduced, and those are called the removable discontinuity, the ones that you can cancel or reduce. The non-removable discontinuity would be whatever is left in the denominator after reducing. So in this problem here, if we're talking about, and we want to know, points of discontinuity, we would first want to try to reduce this and simplify. So we would factor the numerator and denominator. Minus 3 times x minus 1. And now you can look and see, okay, well, I have types of discontinuity. Normally we would say that this is x cannot equal 3 and 1, and then we would cancel to simplify this, and then we would be left with 1 over x minus 1. Now, the removable discontinuity is the one that can be canceled. The non-removable is the one that is not canceled. So 1 is not canceled, and so that would be considered non-removable discontinuity. So that's how you determine the difference between two types of discontinuity. Now, here's the thing. Your non-removable discontinuity has a specific purpose in your graph, and it is called our vertical asymptotes. Now, your vertical asymptotes are very, very important. And one thing that you do need to know is, what is an asymptote? So an asymptote is an invisible line that acts as a barrier for the graph. A barrier meaning that your graph will not touch or cross this line. Now, vertical asymptotes are like they sound. They're vertical lines. So in this case up here, our non-removable discontinuity should be our vertical asymptote. If we were to draw that, this is how it would look. We would go to x equals 1, and we would draw a dotted line that is vertical at x equals 1. So this is the line x equals 1. Now, we draw a dotted line because it's considered an invisible line. That means it's not a part of your actual graph. So that means this line is not included. And that's how we would identify. Remember, a solid line would identify included graph, or included lines, and a dotted line would act as the non-included. So this is an asymptote, and this is how we identify vertical asymptotes. They are our non-removable discontinuity. Now, there are such things as horizontal asymptotes, and we need to talk about those next. So your horizontal asymptotes come from your horizontal asymptote test. Now the horizontal asymptote test is written here. So you can take a minute and pause and write it down. We're going to talk about it really quickly. The first thing that you need to know is that there are 3 different types of horizontal asymptotes that you could get. One, you could get a horizontal asymptote that is y equals 0. So this is the first type. Sorry, let me change colors. This is the first type, y equals 0. The second one is y equals a over b. And then the third one is does not exist. That means there is no horizontal asymptote. Now, where does this n and m come from? Because we have 3 statements here. N is either less than m, equal to m, or greater than m. So where does n and m come from? Well, it's technically the exponents from your first term. So these right here represent our first term in the numerator and in the denominator. So the exponent of our first term is n, and that's in the numerator. The exponent m is the of the first term in the denominator. Look at our exponents. Now, a and b I left here. A is the leading coefficient in the numerator, and b is the leading coefficient in the denominator. So a and b are leading coefficients. So if I were to ask you what is the horizontal asymptote of y equals 2x over x minus 3, you would first look at the exponent in the numerator. Well, the exponent in the numerator is 1 because there is no exponent, so we understand it to be 1. Exponent in the denominator is 1 as well. So in this case, n is equal to m. That's our second case here. So we have these three cases here. I have n is less than m and n is equal to m. N is greater than m, you would not have anything. So I don't really focus on that one. I focus on the other two. But if n is equal to m, then we say, okay, well, our horizontal asymptote is y equals a over b. Well, what is a? The leading coefficient in the numerator, and b would be the leading coefficient in the denominator. So a would be 2, because that's the leading coefficient in the numerator, and b would be 1, because that's the leading coefficient in the denominator. So my answer would be y is equal to 2. That would be my horizontal asymptote. Canceled or reduced here, so your vertical asymptote from before would be your discontinuity. Where is this not continuous? That would be x equals 3. So x, remember, it cannot equal 3, so our vertical asymptote we say is x is equal to 3. And that is how you find your vertical and horizontal asymptotes. In order to graph these, you have to know how to find your vertical and horizontal asymptotes. So we're going to go over some examples on how to graph these problems. And then I have 2 examples to do, and then we will be done for this video. So our first one is to sketch the graph. Now, let's go right into what we just did. We talked about our vertical asymptote and how to find it. We talked about our horizontal asymptote and how to find it. The first thing that we need to make sure we do, though, is always to make sure it is simplified first. In this case, nothing can be factored, nothing can be canceled, so therefore it is completely simplified. So we need to find our horizontal and vertical asymptotes. So go ahead, take a second. I'm going to get set up for graphing, and you identify our horizontal and vertical asymptote. Now from our discontinuity, we would know that our vertical asymptote would be equal to -2, or can equal 2, but it would be, that would be the line we draw, is x equals 2. Our horizontal asymptote would be, if you look at n and m, n is equal to m, so therefore y is equal to a over b. So it's the same one that we did before, because its numerator has an exponent of 1, denominator has an exponent of 1, so therefore now it's y equals our leading coefficients, which is going to be 1 over 1. We don't worry about the 4 and 2, we're worried about the others. So it's going to be y equals 1. So go ahead and draw those asymptotes. That's the important part, is we're going to go ahead and draw those asymptotes. And I like to do things in different colors. So y equals 1 is a horizontal asymptote, so I'm going to do a dotted line at y equals 1. X equals -2 is a vertical line, so I'm going to do a vertical line at x equals -2. So these are considered our boundary lines, these dashed dotted lines. They're not actually a part of our graph. So now we need to know, okay, well, I need to know what's going on with this graph, so I need coordinates. And the easiest way to do coordinates is to find either your x and y-intercepts, and any additional points that you may need. So the first thing is to find your x-intercept. Let's review that. To find your x-intercept, you set your y equal to 0. Well, if I do that here, my y equal to 0, that would be 0 minus 4, or no, I'm sorry. I went into the other thing. That would be 0 is equal to x minus 4 over x minus 2, and then we would solve. Now, here's the thing. Because you have a simplified function over here, it should always be the same steps. Multiply both sides by x minus 2. And I get 0 is equal to x minus 4. Then I can add 2 to both, or 4 to both sides, and I get x is equal to 4. Now, another way to do this and to think about this would be to set the numerator equal to 0. That's a kind of a shortcut. Instead of setting y equal to 0, you can set your numerator equal to 0, and that will find you your x-intercept. So we have an x-intercept at x equals 4. So if we go to x equals 4, 1, 2, 3, 4, I should have an x-intercept there. Now we need to find our y-intercept. So your y-intercept is going to be found by setting x equal to 0. That's what I tried to do earlier. So if I set x equal to 0, I'll do this underneath, I have 0 minus 4 divided by 0 plus 2. So this will be my y-intercept. So I have negative 4 over 2, which equals negative 2. So at negative 2 for y, I have another coordinate. So we can go up here and graph that. At negative 2, I have another coordinate. So y is equal to negative 2. Now, our graph is in this quadrant here, and it connects like this. So it approaches those lines, because that's what asymptotes do, approaches both asymptotes, but it never crosses them. So you're always going to kind of draw it in this like smooth like motion where it approaches the line, but it never crosses them. Now the problem is that we're not really done, because we only know what's happening on this side of the vertical asymptote. My graph will never be above and below at the same time, because it's not considered a function. You can't have a graph above and a below at the same time. But I could have something over to the left. So I need to know what's happening to the left. So this is where we choose a point, okay? And we're going to choose a coordinate, and it's going to be an x value to the left, sorry about that, or right of my vertical asymptote. So I'm going to choose an x-coordinate to the left or the right of my asymptote. Now I already have x-coordinates to the right, so I don't need to choose x-coordinates to the right. I just need to choose x-coordinates to the left. Now, my vertical asymptote is x equals negative 2. Directly to the left is x equals negative 3. I am going to choose directly to the left and test x equals negative 3. So what that will do is it'll give me an additional point to graph. So I have y is equal to negative 3 minus 4 over negative 3 plus 2. So now negative 3 minus 4 is negative 7. Negative 3 plus 2 is negative 1. So my answer is going to be 7. So at negative 3, my value is up at 7. That's a coordinate we can graph. Negative 3, comma 7. So we plugged in negative 3, we simplify, and we get an answer. Now that is how we're going to finish our graph. We're going to go to negative 3, up 1, 2, 3, 4, 5, 6, 7. If you had done negative 4, it would have put you at positive 4. It's 1, 2, 3, 4. And you notice that it's going down. If I had done negative 5, negative 5 minus 4 would be negative sorry, negative 9, and then divided by negative 3. So negative 9 divided by 3 would be positive 3. And you'll see it just kind of continues to go down. So what you're really looking at here, 1, 2, 3, 4. Oh, I put that too high. I apologize. What you're really looking at here is, so I have 1, 2, 3, 4, 5, 6, 7. Yeah, that one's right. Is this one that was wrong? I apologize. So now what we're really looking at is we have the graph that connects these 2 points. Now I only need 1 point. I just need to know what quadrant it's in, and then I can just draw my graph, okay? But I didn't need the extra point. I just needed 1. But you could pick any point you want, and it'll still be above or below, okay? It's not going to be both. So that is how you're going to graph and sketch these functions. I don't want anything more than that. I don't need a lot more than that. You don't need a lot more than that. This is, if you were going to get an exact value, you would go ahead and graph it on a graphing calculator or utility instead of this. So let's go ahead and recap really quickly what we did to graph and all the steps. So first, to sketch. So the first thing that we're going to do to sketch is we're going to simplify. Sometimes you can, sometimes you can't. Make sure it is simplified first. Second, you're going to find your vertical asymptote. Third, you're going to find your horizontal asymptote. Those we talked about earlier in this video. The fourth thing is going to be to find additional coordinates. Now there are 3 types of coordinates you can find. The first one is y-intercepts, where we set our x equal to 0. The second one is x-intercepts, where we set y equal to 0 or my numerator equal to 0. That's a shortcut, okay? And then the third is where we choose x values on the left or right asymptote. Now sometimes this happens and you need to do it, and sometimes you don't. It really just depends. Now you can also have some of these work and some of these not work. So you do not have to have an x or y intercept. You could have, you know, one of those or none of them. But you should have values on the left and right of the vertical asymptotes. Now, for example, let's do one more graphing. Y is equal to 2 over x minus 3. So go ahead and find all those things if you can. Pause it and find everything. See if you can get the graph right, and then we'll do it together. So notice that this is already simplified. I don't need to do anything for simplifying, but I do still need to find my vertical and horizontal asymptote. So your vertical asymptote comes from the denominator. That's going to be x equals 3. So whatever makes that denominator 0, that's your vertical asymptote. My horizontal asymptote is going to come from the horizontal asymptote test. Now n in the numerator is not 1 anymore because there's no x. So n is equal to 0. And m is equal to 1. That means n is less than m. So your horizontal asymptote is y equals 0. So we can go ahead and graph those. I'm going to graph a point at x equals 3. Not a point, but a line. That's the vertical. And then y equals 0 is this line, y equals 0. Make sure you draw a horizontal line to note that it's different, and you might want to have it there so that you don't make a mistake. Now this means if it's the x-axis, that means that we really shouldn't have an x-intercept, and you'll see that in this next step. So first I would try to find my x-intercept or my y-intercept. It doesn't matter which one you do first, but let's say I look at my x-intercept. That's where the numerator is set equal to 0. Well, my numerator is 2, and 2 cannot equal 0. So therefore, there is no x-intercept. So then I want to find my y-intercept, and in this case, my y-intercept is 2 over 0 minus 3. That would be negative 2/3. Now just roughly estimate negative 2/3. It's going to be down here somewhere, and it's going to be less than 1 or negative 1 or greater than negative 1 and less than 0. So I already know now that this is part of my graph. And that part of my graph is in this quadrant. So now I need to know what's happening to the right of my graph. Well, my value is at 3. Then I can pick something at 4. I could pick something at 5. I actually chose 6 for this one just to be random. But I chose x is equal to 6 because that's to the right of my value here. 2 divided by 6 minus 3 gives me 2/3 as well. So this is a positive 2/3. So that means at 6, 1, 2, 3. So 1, 2, 3, 4, 5, 6, I'm at positive 2/3. And I just graph it there, and then I can just draw my graph in that quadrant. So you should have a graph that looks like this. You should have an y-intercept here. You should not have an x-intercept, and you should have the other graph over here. Now, it doesn't matter what point you chose. It doesn't matter what point you graphed. As long as it's in that quadrant, you are good. So that is how we graph these, okay? So you're going to go ahead and complete the assignment on Canvas, and I hope you have a wonderful day.